So, good morning, everybody, and welcome to this new lecture of the school Emergent Electronic States Confined Interfaces. It's a real pleasure for me to be with you online today, and I would like to thank the organizers and particularly Mark for the kind invitation to teach during this school. I was very excited at the idea to go to Les Houches and to spend 1 week with you there. It's not possible today, and we are confined at home and working online, but it's certainly better than nothing, and I hope you will enjoy this lecture. My lecture today is entitled From First to Second Principles Theory of Oxides. Initially, I think the title was From First Principles to Landau Theory of Oxide, but I broadened it a little bit just to include some more recent second principles methods that I will present during my talk. So the outline of my talk is the following. I will start with a brief introduction about oxide interfaces to try to highlight the needs of theoretical description of this interface in order to help identifying the physics that can appear at that place. Then I will go step by step through the different concepts of my title. I will first present first principles theory, focusing mainly on density functional theory, reminding you the basic principles behind this theory and insisting on what we can get and learn from that. I will also mention what are the limitations of this theory, and this will bring us naturally to the second part of the talk, where I will discuss second principles theory. I will first describe what it means and introduce you distinct second principle approaches, focusing mainly on lattice model. And then the most interesting part of my talk will likely be the third one, where I will try to teach you how to go from first to second principle theory. And of course, I need to take specific example, and I will focus on structural phase transition in perovskite. I will introduce some kind of generic methodology to analyze the problem and see how to formulate it properly. And I will illustrate that through a practical example, starting from very simple example like barium titanate to more complex cases like calcium titanate or even yttrium nickelate. So I don't know exactly what is your background, if you are more theorist, more experimentalist. I hope that in both cases you will learn something from this presentation. But in any case, do not hesitate to interrupt me if you have questions during the presentation, or you can do so at the end of the talk.